So you've got a rough layout for your battery. You understand what your voltage needs to be, and you understand what sort of power and current, how you're going to cool it, and what, more importantly, what energy level you need to have in the battery to be able to make it all the way through the endurance race at a reasonable pace, because that's after all the point. If you don't finish, then you don't score. So you've got to finish first. So it's got to be reliable, and you've got to have enough energy. So make sure you understand that. You should have that already from your simulation. So how do we get that energy? What's key to that? We've talked about current, we've talked about voltage. So how do we pull that battery design together? Well, we're quite lucky these days. There's a lot more available on the market in terms of you can buy modules off the shelf. So what's a module? What's a battery? What's the cell? Why do we talk about these things differently? Well, the cell is essentially something, it's a single piece. It's something the size of your thumb, somewhere around the size of a conventional D cell. You'll hear terms like 18650 or 2170. These are just dimensions, and that gives you the size of the cell. 2170 is 2.1 centimeters by 7 long. It's that simple. That cell will have some properties. You can buy them from different manufacturers. You can buy pouch cells. Well, that's something about the size of your passport, and it's got some lugs at the top which you can connect to. Or you can buy, as I say, a 2170. That's a cylindrical cell. But none of these things particularly matter at the moment. What you need to understand is that cells are constructed into modules, and then modules are brought together to form the whole battery. And you start from the ground up by working out how many cells you need in series. That is, if each cell is 4 volts and you've selected a 400 volt battery voltage to support the inverter that you've chosen, you need 100 cells in series. That's just simple multiplication. You don't need to be clever to work that one out. But what you then need to work out is how many cells you need in parallel. And depending on the cell you've chosen, some cells will contain more or less energy. To get your overall level of energy storage in the battery, you'll need to multiply them by a number of what we call parallel strings. So you then end up with 100 cells in series and maybe 5 in parallel, which will give you the typical sort of 5 to 8 kilowatt hours that a Formula Student battery generally ends up being. That'll all depend on your sim, so don't take those numbers as gospel, but the ranges that we see, typically that 5 to 8 kilowatts, or if you've got a really inefficient car, or a particularly heavy car, or a particularly inefficient motor, you might need more than that, but your sim will tell you the answer. So having gone through your cell selection, obviously you then need to go and find someone to supply you cells, and you also need to test those cells. Are they what the actual manufacturer says they are? So then you're testing the cells, you're testing the modules, and you're testing the whole battery. And you will need facilities, skills, and data logging to be able to do that. So these are things that you will need to develop. But it's no different to running an engine on a dyno. And that's quite a dangerous and difficult thing to do as well. So you will need to develop new test methods and new skills to work with batteries. But this is something that we all should be doing right now, and they're good skills that will stand you in good stead for your career.